This is the intro video for the Resistances in Black Boxes experiment. This lab is done a little bit differently than most. For starters, you and your partner will be given individual equipment, and you'll be graded individually, so both of you should bring your own lab books for this experiment. Second, this lab is going to be graded on a pass-fail basis, so there's two parts to the experiment, Part A and Part B, and in both of them you're asked to come up with a solution to some problem. You only get 2 chances to come up with that solution. So for example, in Part A, you'd look at the system, you'd write down your solution for it, you'd show it to your lab instructor. If you got it right, you get 5 out of 5 for that part of the experiment. If you got it wrong, you go back and you try again, and if you get it right the second time, then you get 2.5 out of 5 for that part of the experiment. If you don't get it right the second time, however, you get 0 out of 5. And then you'd move on to Part B, which has exactly the same grading scheme. So that's the downside. The upside to this is that there's no lab report this week. You'll just be graded in the lab. And if you're wondering why we're doing it this strange way, it's because this is what we do instead of giving you a lab exam this semester. We test you one time, independent of your partner, and it's graded very quickly on a pass-fail basis based on your lab skills. So it's not so bad after all. You're doing this instead of a lab exam. In Part A, you're given a box that has 5 light bulbs screwed into it. So make sure that they're all screwed in tightly. And your job is to figure out how they're connected together inside the box. Now the first thing you want to do is write down the ID code that's on the end of the box. That's what allows your lab instructor to check your work. And I'm not going to show you this box, I'm going to show you this one instead. And you want to hook up power across these and study how the light bulbs light up. So first of all, turn on your power supply, and you want to set the current all the way to maximum, and then turn up the voltage to 12 volts. Then you can plug in your box, and all of the light bulbs should light up, although some of them do light up fairly dimly, so you can probably see it a little better there. They all are lit up. One of them's brighter than the others. And your job is now to figure out how things are connected inside the box. And the way in which you do that is you can unscrew light bulbs and see what effect it has. So you can unscrew them one at a time, or in clusters if you want. But you figure out, based on how the electricity flows or doesn't flow, and how bright things look, how these things are connected inside. The lab manual suggests that you should draw something like this to describe how things are connected. So this would describe 2 light bulbs in series with each other, and then 3 in parallel with one another, then connected in series with these 2. So you'd have some diagram like this, explaining to your lab instructor how you think these light bulbs are all connected together. When you think you've got the solution and you've drawn it out, call your lab instructor over to check it. In Part B, you don't need a power supply, you just need a multimeter that you can use to measure resistance. So again, you're given a box, and there are 4 pickup points where you can plug in the terminals of your ohm meter and measure what the resistance across any 2 points are. And you can do diagonals as well. So again, write down the code that's on the side of the box, and also note that they tell you that there are 4 resistors inside, and they give you the nominal values of them. So you want to write this information down and keep in mind that these values are only accurate to about 10%. And again, I won't demonstrate on that one, I'll demonstrate with this one. You would turn your multimeter to the ohm scale, so it's now acting as an ohm meter, and then you measure the resistance across various points. And so you do every combination that you can, and get a value for all of them. And then your job is to figure out how these 4 resistors are connected inside. So the lab manual suggests that you might want to, for your own benefit, draw something like this. So these are the 4 points, and you just write in what you measured across each of them. So there's your resistances for the various legs. And then you figure out how things are connected inside, given that you do know what the value of the resistances are. And when you're done, the diagram that you're going to show your lab instructor for them to check will look something like this. So again, this is straight out of the lab manual, where they've drawn A, B, C, and D, the 4 pickup points on their box, and then put in their best guess for how the 4 different resistors are connected to each other. Note that you can have bare wires inside there in addition to the 4 resistors. However, there will never be a connection where a bare wire shorts out one of the resistors. And again, when you think you've got your answer, call your lab instructor over to check it. Once you've been assigned your grades, you're free to go, and there's no lab report to hand in for this experiment.